Good morning, students. Today we are going to learn the chapter Measures of Dispersion, and today's topic is range, mean deviation, standard deviation, and coefficient of variation. Measures of dispersion. You have learned various measures of central tendency, that means mean, mode, and median. Measures of central tendency helps us to represent the entire mass of the data by a single value in the form of mean, mode, and median. Can the central tendency describe the data fully and adequately? In order to understand it, let us consider an example. The daily income of the workers in two factories are Factory A and Factory B. Factory A having 35, 45, 50, 65, 70, 90 and hundreds, and Factory B having 60, 65, 65, 65, 65, 65 and 70 are the data of two various factories, Factory A and Factory B. Here we observe that in both the groups, that means Factory 1 and Factory 2, the mean of the data is the same. That means 65. The mean of Factory 1 is also 65 and mean of Factory B is also 65. In group A, that means Factory A, the observations are much more scattered from the mean. In group B, almost all the observations are concentrated around the mean. Certainly, the two groups differ even though they have the same mean. Both Factory A and Factory B, the mean is the same, but the data scattered largely from mean. It is observed in Factory A, and data is closely nearer to the mean. It is observed in Factory B. Thus, there arises a need to differentiate between the groups. We need some other measures which concern with the measures of scatteredness or spread. To do this, we study what is known as measure of dispersion. Meaning of dispersion. To explain the meaning of dispersion, let us consider an example. Two sections of 10 students, each in class 10, in a certain school, were given a common test in mathematics, and the maximum marks are 40. The scores of the students are given below. School A, that means section A, having the 6, 9, 11, 13, 15, 21, 23, 28, 29 and 35 are the score of 10 students in the subject of mathematics in school A, and in school B 15, 60, 16, 17, 18, 19, 20, 21, 23 and 25 are the 10 observations of the students getting the mass in mathematics subjects. The average score in section A, that means school A, is 19, and the average score in section B is 19. That means the mean of both the school of 10 students is 19. Let us construct a dot diagram on the same scale for section A and section B. The position of mean is marked by an arrow in the dot diagram. Now this is section A, that means school A. The data is scattered from the mean, and school B, the data is very closer to the mean. Both schools, the mathematics subjects, 10 students data, its mean is 19, but school A having the scattered data from the mean and school B having the very closer data from the mean. Clearly, the extent of spread or dispersion of the data is different in section A from that of section B. The measurement of the scattered of the given data about the average is said to be a measure of dispersion or scatter. In this lesson, you will read about the following measures of dispersion: range, mean deviation from mean, mean deviation from median, variance, and standard deviation. Range. In the above cited example, we observe that the scores of all the students in section A are ranging from 6 to 35. The initial value of our data and the final value of our data is known as the range of our data. The score of the students in section B are ranging from 15 to 25. The difference between the largest and the smallest score in section A is 35 and 6. The lowest value is 6 and highest value is 35. The difference between the 6 and 35 is 29. The difference between the largest and smallest score in section B is 10. The smallest value or initial value of our data is 15 and final value or largest value of data is 25. A difference between 15 and 25 is 10. Thus, the difference between the largest and the smallest value of the data is termed as the range of the distribution. Mean deviation from mean. We note that the score in section B cluster around the mean, while in section A the scores are spread away from the mean. Let us take the deviation of each observations from the mean and add all such observations or deviations. If the sum is large, the dispersion is large. If, however, the sum is small, the dispersion is also small. The formula for calculation of mean deviation is equal to sum of x 1 minus x divided by n. N means number of observations. Let us find the sum of deviation from the mean. That means 19 for score in section A and section B. Both section A and section B, the mean of the section A data and section B both are same 19. The mean deviation means deviation from the mean. The observations, mean minus observations. Your mean is 19. That means 6 minus 19 is equal to minus 13. Observations are minus from the mean. 9, 19, 9 minus 19 is equal to minus 10. 19 minus 11 is equal to minus 8. 13, that means 19 minus 13 minus 6. 15 minus 19 minus 4. 21 minus 19 plus 2. 23 minus 19 plus 4. 28 minus 19 plus 9. 29 minus 19 plus 10. And 35 minus 19 plus 16 are the observations of section A. Its total is 190 and mean is 90. Sum of all observations divided by number of observations. Number of observations are 10. 190 divided by 10 is equal to 19. 19 is the mean, and in mean deviation, observations minus your mean is equal to mean deviation. The mean deviations are plus or either minus. The total of plus minus is 0. The observations, section B, observations are 15, 16, 16, 17, 18, 19, 20, 21, 23 and 25. Its total is also 190. 10 observations. Mean means sum of all observations divided by number of observations. 190 divided by 10 is equal to 19. The same mean for section B is also 19. And 15 minus 19, 19 is the mean. That means 15 minus 19 is equal to minus 4. 16 minus 19 minus 3. 16 minus 90 minus 3. 17 minus 19 minus 2. 18 minus 90 minus 1. 19 minus 90, 0. 20 minus 90 plus 1. 21 minus 19 plus 2. 23 minus 19 plus 4. 25 minus 19 plus 6. Mean deviation is also 0. Here this sum is 0, section A. It is neither larger nor smaller. It is a coincidence. Again the sum is 0 in section B. Certainly it is not a coincidence. In fact, we have proved earlier that the sum of all the deviations taken from the mean is always 0 for any set of data. Why is the sum always 0? On close examination, we find that the sign of some deviations are positive and of some others deviations are negative. Perhaps this is what makes their sum always 0. In both the cases, we get sum of deviations to be 0, so we cannot draw any conclusion from the sum of deviations. But this can be avoided if we take only the absolute value of the deviations and then take their sum. If we follow this method, we will obtain a measures called the mean deviation from the mean variance. In the above case, we took the absolute value of the deviations taken from mean to get rid of the negative sign of the deviations. Another method is to square the deviations. Let us therefore square the deviations from the mean and then take their sum. If we divide this sum by the number of observations, that means the sum of the frequencies, we obtain the average of deviations, which is called variance. Variance is generally denoted by S2. Standard deviation. If we take the positive square root of the variance, we obtain the root mean square deviation, or simply called standard deviation, and is denoted by S. This is the formula for calculation of standard deviation. Standard deviation is equal to under root of sum of x minus x bar square divided by n, that means number of observations.